Welcome to the Audiophile Analysis Speech Processing Basics demo. In this demo, we will understand how to analyze an audio or speech signal with Python. To do so, we'll be using some Python libraries. Python has some great libraries for audio processing, including librosa and PyAudio. There are also a few built-in modules for basic audio functionalities. Let's get started. To start, go to the Start menu of your window and open the Jupyter Notebook. Once the Jupyter Notebook is initialized, you'll see a link that redirects you to the browser. Once there, click on New and then Python 3 to create a new Jupyter Notebook using Python 3. Now, let's rename this file as Analysis of Audio Files. Now let's see how to implement this project. First, we need to import the required packages, including librosa, using the import command. Librosa is a Python module which is used to analyze audio signals. In general, you can load any audio file using this and work on it. After importing librosa, specify the audio path that needs to be imported. To load the file, let's use the load function. This is x,sr equals librosa.load and then the audio path, which is the full path to the audio file. This will load the audio file mentioned in that path that you just put in. Please ensure that the complete path of the audio is specified. If not, show the steps shown on the screen. Now click the Run button to run the code. Now, let's play this audio file directly in Jupyter Notebook using the ipython.display.audio method. To use this method, we need to import ipython.display as IPD and then pass the audio path as a parameter to the ipd.audio function. Run the code, and you can now play the audio directly from within Jupyter Notebook. To check, play the audio once. Now, let's visualize this audio file. We can plot the audio array using librosa.display.waveplot. First, let's import matplotlib, saying import matplotlib.pyplot as PLT, and import the librosa display package using import librosa.display. Now let's specify the figure size. This is the size of the output plot. And then plot the wave plot by using, or rather passing, the audio as a parameter. Now run the code and you can see the output. Let's try to display the spectrogram. To do this, let's use the stft function, which converts data into a short-term Fourier transform. It's used to convert signals such that we can determine the amplitude of a given frequency at a given time. We also use the specShow function to display the spectrogram. The code for this is as follows. X equals librosa.stft of x. xdb equals librosa.amplitude underscore to underscore dB. And there we pass in the ABS, or absolute value, of capital X. Next, plt.figure, passing in fig size equals 14,5. That's the size of the plot that you'll see. And then librosa.display.spectshow, passing that the parameters xdb, sr equals sr, x underscore axis equals 39, time equals 39, y underscore axis equals 39, and finally hz equals 39. Hz is hertz. And then finally, enter plt.colorbar. Now run the code and you'll see the output in the form of a color bar. The vertical axis here shows the frequencies from 0 to 10 kilohertz, and the horizontal axis shows the time of the clip. Since we see that all this action is taking place at the bottom of the spectrum, we can convert the frequency axis to a logarithmic one. So let's now interchange the axis using the code below. librosa.display.spectshow, passing in the parameters xdb, sr equals sr, x underscore axis equals time, and this time y underscore axis equals log. Now we print that out using plt.colorbar. Now run this code and you'll see the output with the interchanged axis. Now let's write this output to a file. To do so, we use the librosa.output.write underscore WAV function. It saves a NumPy array to a WAV file, and you can write this output of any audio file to another audio file as and when required. Let's specify the path of the file to which we need to write the audio. Now run the code, and you can see that a new file has been created as example.wav with all the data written into it. Here, we have successfully completed the analysis of an audio file.